This is a teaching video to cover section 18.4, which deals with applications that involve the skills you've been learning. So we'll start with finding values or finding formulas that are for a different variable than it's set up to give you. For instance, in this formula, E equals Pn squared, you are to find out what N equals in terms of E and P. So you're going to use skills that you already know to isolate N on the left and have it equal to something on the right. Let me show you how to do that. First we want to let's turn it around so that N is on the right because that's what we're used to. So we get Pn squared equals E. And then to get the n squared term, the n term on the right, we are going to divide both sides by p. And now all we have to do is take the square root of both sides. And that will give us n on the left. So we have n equals, and I'm going to break it up to be the square root of e over the square root of p. And now we have to clear that square root of p from the denominator because it's a radical. You can't have radicals in the denominator. So we multiply by 1 in the form of square root of p over square root of p. And now what we have is that n equals the square root of e p over p.
Right.
Let's look at our next formula. And in this formula, we also want to isolate n. So the first thing we're going to do is to multiply both sides by n squared. That will clear the n squared term from the denominator as follows. We're going to multiply the left by n squared and also the right by n squared, only we'll do that as a fraction, n squared over 1. And now you can see that the n squareds cancel. So at this point we have n squared f equals ki. Let's isolate these n term or n factor by dividing both sides by f. And then these f's cancel. And we then have n squared equals ki over f. So we apply the square root property, and we have n equals, and then I'm going to break up the square root, ki on the top, square root of f on the bottom, but I need to clear the radical from the bottom, so I multiply by the square root of f over the square root of f, and that gives me n equals, and then I can combine all of the radicals, and then on the bottom the square root of f times the square root of f is the square root of f squared, which is just f. So now I have isolated this formula in terms of n. This is a really important skill in any kind of scientific or technical or medical field. The next formula has n showing up in 2 terms, and that's going to be tricky because you can't just multiply and divide to clear out the n, but what you can do is use the quadratic formula. So let's move our n's to the left, just reverse, switch around what's on either side of the equal sign. So we have vn squared plus mn equals r, and then we subtract r from both sides so that we can set it equal to 0, and when it's set equal to 0 we can solve it. So let's do a quick refresh on the quadratic formula. If you have a, let me do it in a different color ink. If you have ax squared plus bx plus c equal to 0, you can solve for x using the quadratic formula, which says negative b plus or minus the square root of b squared minus 4ac over 2a. Well, this equation is like this equation, only instead of x, we're going to solve for n, which is what our goal is. So, back to black ink, n is negative, and here let me write in a is going to be v, b is going to be m, and c is going to be negative r. So n equals negative b, which is m, plus or minus the square root of b squared, or m squared, minus 4 times a, which is v, times c, which is negative r, over 2a. And so that's going to equal negative m plus or minus the square root of m squared plus 4vr over 2a. And at this point, we have everything. We have n equal to something, and that something doesn't have n in it. And we don't have radicals in the denominator, and we don't have anything that cancels out. So this is our simplified answer. In this problem, you have two ships leaving port at the same time. One heads south and the other heads west. Several hours after departure, the ships are 340 miles apart. So that distance that they're apart is 340 miles. If the Titanic traveled 140 miles farther than the Mayflower, how many miles did they each travel? So the Titanic is the ship heading south. If the Mayflower's distance is x miles, the Titanic's distance is 140 plus x miles, because it travels 140 miles farther than the Mayflower. So when all of these ships do all of these things, they form a triangle where the sides that are on either side of the right angle are the legs, and the other side is the hypotenuse, which is the side that is opposite the right angle. And we know from our Pythagorean theorem that the leg squared plus the other leg squared equals the hypotenuse squared. You probably learned it, a squared plus b squared equals c squared. It doesn't matter if this side is a or this side is a, but one is a and one is b, and then the hypotenuse is always c. So now that we have a formula to work with, we can solve this problem. So for the purposes of using the Pythagorean theorem, we're going to call a equal to x, b equals to 140 plus x, and c equals 340. When we write our a squared plus b squared equals c squared, using our substitutions, we have a, which is x, all that squared, b, which is 140 plus x squared, and c squared is 340 squared. Using FOIL on the middle term, we get 140 squared plus 2 times 140 times x plus x squared. Now I use the actual formula that says a plus b squared equals a squared plus 2ab plus b squared, and you should have this formula memorized by now. So we have x squared plus 140 squared plus 280x plus x squared equals 340. That gives us 2x squared plus 280x plus 140 squared minus 340 squared equals 0. So I combined terms, put them in descending power order, and moved the number that was on the right side of the equation to the left side by subtracting both sides, and then I was able to set it equal to 0 so we could solve it. 140 squared, if you put in your calculator and then subtract 340 squared, you get negative 48,000. So we have 2x squared plus 280x minus 48,000 equals 0. And we have a common factor of 2, so we can divide everything by 2 to bring our numbers down a little bit. And we get x squared plus 140x minus 24,000 equals 0. And now we can apply the quadratic formula where we have a equals 1, b equals 140, and c equals negative 24,000. Now we can write the quadratic formula, which says that x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Inside the parentheses we have 140 squared, and we have minus a negative, which becomes plus a positive. When you figure all of that out and take the square root, it becomes 460. So you have x equals negative 140 plus or minus 460 over 2. And so that means x is either going to equal negative 140 plus 460 is 320 over 2, or x equals negative 140 minus 460, or negative 500 over 2. But x can't equal a negative number because it's a distance, so we know that x is going to equal 320 over 2. So that means that x equals 160 miles, and that tells us the distance that the Mayflower traveled when we look back up at our picture up here. So the Titanic traveled 140 plus x, or 300 miles. And it's always a good idea to check your answer. So if x is 160 miles, that means 160 squared plus 300 squared, the sides squared, should equal 340 squared. And if you put that in the calculator, I think you'll see that that is correct. So your final answer is 160 miles for the Mayflower and 300 miles for the Titanic. Susan wants to buy a shag rug for her living room that measures 12 by 20 feet. She wants to leave an even strip of flooring uncovered around the edges of the room. How wide a strip will she have if she buys a rug with an area of 84 square feet? We can visually organize our information by drawing a picture. The orange represents the floor and the blue represents the carpet. Now we look at the problem and it tells us that the living room, which is the orange, measures 12 by 20 feet. And we don't know what the rug is going to measure, but we know the area of the rug is 84 square feet. And what we are to find is this dimension here that is the same dimension all around the carpet. It's the width of the strip of floor between the carpet and the wall, and we'll call that W. Now the formula we're going to use is that area equals length times width. We don't know the area of the, well, we do know the area of the whole room, but that doesn't help us any. We know the area of the carpet, it's 84 square feet, but we don't know the length or the width. However, we do know that the width we're looking for, the little w, that if you add w plus w together, you get the two strips that are that way. And then you know this total distance is 12 feet. So if you subtract these two w's from this 12, you're left with this length, which is the width of the carpet. So the reason we're going to do that is because if we can come up with an expression for the width of the carpet and the length of the carpet that have this w in it, then we can solve for w using this formula. So we're going to say our capital W equals 12 minus, and then we could say minus w, but we'll just say minus 2w, 2 little w. And our capital length, which is this dimension, is going to be 20. And then in the same way, since this area here is also w and this is also w, it's going to be all of this length minus this little area and this little area. So it's 20 minus 2w. And we know that the area is 84 feet squared. And then we end up with 0 equals w squared minus 16w plus 39. So now we have a quadratic equation, and we can use the quadratic formula to solve for w. W equals negative b, and b is negative 16, plus or minus the square root of b squared minus 4 times a times c. All of that over 2a. And that gives us positive 16 plus or minus square root of 256 minus 156 over 2. And that gives us 16 plus or minus square root of 100, which is 10. All that over 2. So our choices are 16 plus 10 over 2 or 16 minus 10 over 2. So our little w equals 13 or 3. Let's go back to our original picture and let's try if w equals 13. Let's look at the width of the room. The width of the room is 12 feet. So if w was 13, then the width of the carpet would be 12 minus 2 times 13, so it would be a negative number. That is why 13 won't work. But if the width is 3, here, this little width is 3, then the width would be 12 minus 2 times 3, or 6, which is a reasonable answer. So the question asked us what was the width of the floor showing between the carpet and the wall, and the answer is that the width is 3 feet.